Welcome back. In our previous lesson, we learned the standard form for quadratic functions, which is y equals ax squared plus bx plus c. The beauty of the standard form is it tells us where the y-intercept is. The y-intercept, all we need to look at c. Y-intercept, the point is always 0, c. That's y-intercept. Today, we're going to focus on intercept form. The beauty of the intercept form is it gives us the x-intercepts. Let's do a quick sketch. This is our coordinate plane. We have y-axis, x-axis. Let's make a quick parabola, and we're going to label here. You see here is one point. Here's one of the two x-intercepts. Here's another one. If I'm to label it, I'm going to label it, this point is P0, and this point is Q0, and these 2 points are my x-intercepts. And we go back to look at this intercept form. It says y equals a times open close parenthesis x minus p and open close parenthesis x minus q, where p and q are these 2 points, the coordinate pair of these 2 x-intercept. There is a constraint for a. A cannot be 0. Let's continue to talk about it. One more thing. Besides it gives us immediately tell us where the intercepts are, we can also use this to find the axis of symmetry. Recall that when we are working with the standard form, y equals ax squared plus bx plus c, the axis of symmetry is x is negative b over 2a. Now, when we are working with intercept form, axis of symmetry is x is, we're going to add these 2 points, so p plus q, then we're going to divide it by 2. That's how we find axis of symmetry if we use the intercept form. Let us bring back our parabola, and remember this is one of the x-intercepts. So this is a P0. This is another one, that's Q0, which means if we're going to find axis of symmetry, we simply add these 2 points and divide it by 2. And then we shall have axis of symmetry is here. Remember, this is not a perfect graph. The idea is we got the main understanding, the basic understanding of what it looks like and how we should use it. Now, let us practice what we just learned. First, we're going to write down the intercept form right underneath this. So we have x, remember it is minus p, and it is minus q. If it's minus, let's write down our a first. So a, you don't see a number here, you only see a negative symbol, which means a is negative 1. And then you come back to here, you say x minus p. So here should be x minus minus 1, because minus minus is plus. And here is x minus 5, which means p here is negative 1, and q here is 5. All right, once we located what is p, what is q, we're able to write the 2 x-intercepts. So p is negative 1. Remember, one of the point is p0, the other one is q0. They're our 2 x-intercepts. P is 1, which means we can write down this x-intercept is negative 1, 0. And the other one is 5, 0. Remember earlier we also talked about we need to have a axis of symmetry because this parabola is symmetric. Once you get a half and then you fold alongside the axis of symmetry and you can have the other half. Therefore, we're going to write down axis of symmetry is, I'm going to say P plus Q divided by 2. Then I come back here, we're going to say axis P is -1, Q is 5, add together, divided by 2, that is 4, divided by 2, that is 2. Now we have 2 points, 2 very special, beautiful points. They are our x-intercepts. We also have axis of symmetry. Last but not least, we're going to find the y-coordinate of our vertex. Then we'll be done collecting all the information. All right, so we know x is 2. Then we say, when we say x, we say it's 2 plus 1 and 2 minus 5. 2 plus 1, that is 3. 2 minus 5, -3. Then we have negative, negative, positive. 3 times 3, that's 9. So we have a positive 9, which means our vertex, this point is 2, 9. Now it's time to graph it. We're going to graph by hand. And that's our coordinate plan. And we have all these beautiful points we can use. Let's first plot our x-intercept. This is -1, 0. -1, 0. Right here. And we have 5, 0. So 1, 2, 3, 4, 5. That's 5, 0. That's our 2 x-intercepts. Now we're going to graph axis of symmetry is x is 2. 2 is here. I'm going to get axis of symmetry. That's x is 2. Remember, it's folding. Being symmetric is we can fold it in half, fold alongside the axis of symmetry. All right, we need our vertex 2, 9. Let's graph this. Vertex says 2, this is 2, and 9. 2, 3, 4, 5, 6, 7, 8, 9. 2, 9 is right here. I'm going to erase this and make it a little bit longer. Okay, so we got a vertex and we got this axis of symmetry, and we also get a 2 x-intercept. I'm about to connect all these points, then form the beautiful parabola for this quadratic function. But before that, I want to do it even better, is I want to confirm where is my y-intercept. Remember, y-intercept is x is 0 and what is y? So you quickly let x be 0 here. I'm going to change the color. You quickly let x be 0, x be 0, and then find out what is y. So we can do it in head. When x is 0, 0 plus 1, and times 0 minus 5. Don't forget in front we have another negative symbol. So the y-intercept is 0, 5. Now I get one more point. The graph gonna look even better. Time to connect these points. And smooth and momentum. Smooth and momentum. Remember, this looks like a little angled curve here. It's really not angled. It is letter U. Parabola, letter U. Sometimes opening upwards, sometimes opening downwards. Now, we're just finishing graphing, and we start with intercept form. I hope you have enjoyed this practice. Happy learning.